In this video, I will explain you about non-ohmic circuits. So far we have learned about ohmic circuits. What are they? We have a circuit, a conductor in this way connected with the potential difference. Now, when we increase the potential difference, current in the circuit increases linearly, which means there is a direct proportionality in between voltage and current. So these are ohmic circuits, where when we plot the graph in between V and I, that will turns out to be a straight line. But in the case of non-ohmic resistance or non-ohmic conductors, what will happen? It will obey Ohm's law till a particular point, and after that when we increase the voltage, then that will be a non-linear variation. So this one will be the graph. So the previous one was ohmic conductors and this one is non-ohmic conductors. So they will also obey Ohm's law but till a particular point. After that they will deviate. So this is one limitation of Ohm's law. Like certain, it cannot be applied to all conductors. Certain conductors will behave in this way. Then non-linear variation VI. And some other limitations are with semiconductors. It is completely different. Like when we plot VI, voltage and current, so the variation will be like this. When we increase the voltage, so let's say x-axis is voltage, y-axis is current. Now when we increase the voltage, the variation will be, initially there won't be any current, but after particular value that will start building up the current. Okay, and in reverse bias it will be in this way. So this is VI graph of semiconductors. Anyway, this is a non-linear variation. And semiconductors, I'll give you the introduction with chapter semiconductors when we start that chapter. Okay. Now as of now you can learn this will be the graph. This is VI graph and you can also plot, this is IV graph. You can also plot VI graph which is given in your NCERT textbook. So either learn this one or learn VI graph. Both are fine. Just for the limitation you should be giving the graph in the answer sheet and also should be giving the explanation that the variation of voltage or variation of current with voltage is non-linear here in this case, and this is called as forward bias and this is called as reverse bias. I'll give you a small concept about forward bias and reverse bias. Now I have connected, see, this end of the conductor with positive and other end of the conductor with negative. Now let's say I am going to reverse this one. So the same battery, now I am going to connect the positive terminal here and negative terminal here. So the first one was forward bias and other one is reverse bias. But anyway with a conductor we don't have positive and negative, right? But we will have it with semiconductor. A semiconductor, for example a PN junction, this one is a PN diode, it will have positive and it will have negative. So this positive when connected with positive of a battery, that is forward bias. So this is the characteristics of forward bias. When we are increasing voltage, initially there is no current, after that there is some current. Now reverse bias is nothing but this is a diode and we are connecting positive with negative terminal and negative with positive terminal. So the triangle is positive, the bar is negative. When we are connecting in this way, that is reverse bias. That is this part. This is first quadrant and third quadrant represent the reverse bias and the graph will be in this way. So anyway, in short, semiconductors that doesn't obey Ohm's law. And some other elements are nothing but gallium arsenide, where it will increase initially, then non-linear variation, then a dip. Okay, so initially what will happen? Voltage increases with, current increases with voltage till a particular value, and after that what will happen? Current decreases when you are increasing voltage. So this is GaAs. So this one is voltage, this one is current. So GaAs, gallium arsenide, you have to give as an example for limitation of Ohm's law, and some element that is non-ohmic circuit you have to give as an example for limitation of Ohm's law, and semiconductor. So these graph will give you 3 marks in 3 marker questions. Okay, thank you.